Here in this video, we are solving two problems that appeared in NEET 2023. Let us see what are the problems are, right. First problem is this. An AC source is connected to a capacitor C. Due to decrease in its operating frequency, what happens? See, let us try to understand what he meant to say. There is a capacitor. It is connected to a AC source having a standard frequency N. Now this capacitor opposes the flow of the current, and the opposition is called capacitive reactance. Capacitive reactance. We know the capacitive reactance is Xc, that equal to 1 by omega C. Omega is 2 pi n into C, that is Xc. Now he is saying due to decrease in its operating frequency, now the frequency decreases. As the denominator decreases, the resultant factor Xc has to be increased. So in capacitive reactance increases is the answer, but unfortunately capacitive reactance remains constant, decreases. These options are given, both of them are wrong. That means you don't have an answer in that sense there. Now what else we can also write is current, displacement current. The current that happens in the AC source is called displacement current. Like V equal to IR, I equal to V by R, we can write a formula here something like V is nothing but the voltage that happens in the circuit. Due to this AC source there may be some voltage, and in the place of resistance I have to write Xc. As Xc has been increased in the denominator, current decreases. So the displacement current decreases is the right answer. Displacement current increases is not the right answer, rather it decreases is the right answer to that question. Let's have a look at the next question, 23. In a plane electromagnetic wave traveling in free space, electric field component has some frequency and amplitude, means electric field strength. What is the amplitude of oscillating magnetic field? The first thing that you need to understand is, in an electromagnetic wave, the electric force and magnetic force are acting on a particle perpendicular to each other, and each force cancels the other. Force due to the electric field is force due to the magnetic field. Electric field is EQ. Force due to the magnetic field is BQV. So velocity that it acquires equal to electric field by magnetic field. Here of course it's being electromagnetic wave, what the velocity that occurs is the velocity of the light, that is c. Now you need to calculate B, that can be written like E by C. E is 48, C is 3 into 10 power 8 meter per second, and this data is not required actually to solve this problem. So this is going to be 3 ones is 3, and then 18 3 6s are 18, that is 16 into 10 power minus 8, that is 1.6. If you have to make 16 into 1.6, you have to divide with 10. So to compensate that, you have to multiply with 10, that is into 10, that is 1.6 into 10 power minus 7 Tesla. Magnetic field strength, its unit is Tesla. So 1.6 into 10 power minus 7 Tesla is the answer for that problem. That's it, and thank you for watching.